Welcome to the Algebros. I'm Bree Bass.
And I am Ka.
Today is February 11th, 2018, and we are recording at Townhouse 72C. The topic that we are discussing today are integrals. Ka, what do you think of when I say integrals?
Integrals. I think I've heard it a few times during my calculus class.
Yeah, me too. I would like to think everyone is informed about derivatives here, but not integrals. Let's take the next step forward into this journey.
Yes, I believe the first stop of our idea of our knowledge train here should be the stop of the antiderivative. You know?
Yeah. So, what is an antiderivative?
Well, I mean, to first understand what is an antiderivative, we must first be comfortable with the derivative. You know? So are you comfortable with the derivatives?
Yes, I am. Remember, we talked about them last week on our podcast.
Oh yeah, perfect. By the way, last week's job, we did a good job there. Yeah. So let's talk about antiderivative. So what's better than to start off with an example? You know. So let's say you bought a Bitcoin on, say, a random date. Let's say November the 1st. Okay.
All right, Ka.
And as we all know, you know, the price of Bitcoin has been dropping. I mean, I feel bad for our audience out there who has been investing in Bitcoin. You know, I just feel bad about that. So if, say, we're mapping out how much dollar Bitcoin has dropped since we brought it. I didn't brought it, you know, it's a bad investment, but if, say, someone brought it. And if you just, record the days that they bought Bitcoin since November 1st, and you take that to the power of 2 times 50, or say in the formula, 50t, where t is, you know, date, 50t to the power of 2, to the power of 2. Now, if we differentiate it, what will we get?
You'll get the rate of Bitcoin dropping, or 100t.
Well, I mean, we learned from last week's what's differentiation, right? So an antiderivative is essentially the opposite process of a derivative. So if you antiderivative the rates of Bitcoin dropping, or 100t, what will you get?
You will get 50t squared.
Well, so that right there is the second fundamental rule of calculus. If you can differentiate a formula into a B formula, you can always anti-differentiate B back into A.
Does that work for any formula?
Well, not any formula, only if the function is continuous. Now, let's go through the correct way of formatting them.
The correct way to format the rate of Bitcoin dropping would be f prime of x equals 100x with respect to x.
Precisely. That was pretty good. Pretty good math there. So when we take the antiderivative, we'll end up adding 1 to the power of number. We'll end up adding 1 to the power of the number of days. Keep in mind, that is our t there. And we'll divide it by the rate of 2. So in our case, 100 will goes to 50, and t to the power of 1 will goes to t to the power of 2. Now, when I say divided by the rates of 2 there, because the t1 eventually goes to t to the power of 2, that's where we get a t there. So eventually, if we get t to the power of 4, we'll actually divide it to the power of 4 there.
Yes, so you can, when you take the derivative of it, you will end up with the same of your beginning starting point. If I would go off and put that in a formula, f of x would be equal 50x squared.
That's pretty accurate, right? So another name for antiderivative is simply integrals. And to be honest, that's a way easier to pronounce word than, you know, antiderivative. Antiderivative, I mean, who would even come up with that?
Yes, another useful method to find the integral is by finding the area underneath the curve of the mapped out formula or function of what you want to integrate. Coincidentally, this is also one way to visualize and understand why integrals work.
So, Bree, do you know physics?
A little bit.
So, we all know from physics that if you graph out the acceleration of, say, a car moving, you know, the acceleration of it, and you take the area under the graph, you find the velocity of the same car, right?
Yeah, going from acceleration to velocity, I believe that is the same thing what we're doing with integrals.
Precisely. It is the same as integrals. I mean, so if you understand, like from fifth grade physics stuff, that like, you know, how to change from acceleration to velocity by just plotting in the graph and just, you know, finding the area underneath. You have actually understood how integrals works. You just never realized that it was, you know, integrals.
That's interesting. Can we do another example?
Okay. I mean, the Winter Olympics is like near, right? So let's do a related one. So let's say you know, the Olympic swimmer there, you swim as a constant rate of inch per second for say 10 minutes. To find how far you swam from point A to point B, you integrate that, right? Now, so one way to do that is to map it out and find the area under point A to B. Now your answer there will be the distance that you have swam.
So that is considered a definite integral, right?
What? A definite? What?
There are two types of integrals.
The two? What are the types?
You have definite integrals when you know precisely from which point A to point B you want to calculate, like our swimming example.
Oh, okay. So say if you swam for like, I don't know, 10 minutes, well, that would be our B, right? So, and say you start from 0 minutes, you know, that would be our A.
Yeah, and to make our swimming example an indefinite integral, we will remove the bounds. So when we take the antiderivative of it, we will get the function plus a constant.
Well, it seems like you can use that function that we would have found to find a distance you swam for any time A to any time B. And I feel like that would be the indefinite integral of the rate that you're swimming in.
Yeah, it makes sense because if you swim for a longer time, you will swim for a longer distance. Without the bounds, we can find the distance you swim from any point of time. So using that example, let's talk about the fundamental rules of calculus.
Huh, interesting. So it's actually the time B, which is like, you know, the time that you have swam, rather than that's like, you know, any x there. That is ultimately the determining factors, or math, you know, we'll call that the variable x.
That fits into the fundamental theorem of calculus rule number 1. So there are two fundamental theorems of calculus.
Well, what's other two?
The first one is if f is continuous on a given interval, a to b, and g of x equal to integral a to x, f of t with respect to t, then g prime of x is equal to f of x.
Well, I mean, we already have proved that, right? I mean, when we have proved that time b, or, you know, x, is actually the determining variables here through the previous, you know, Olympic swimming example there.
Yeah, let's go through the second rule. We hit on it a bit, but I just want to make sure we understand it.
So the second rule where it's like, if f is continuous at given intervals a to b, then it integrates a to b fx dx will equals to yb minus ya, where in this case y is the integrals of f. So Bree, why is it like yb minus ya?
Well, we explained why the area underneath a continuous function is the integral of the function, right?
Yeah. We explained that earlier, right? Yeah.
So if I want to find the distance you swam from 2 to 10 minutes, if I input 10 minutes, you will only get how far you swam from 0 to 10 minutes.
Oh, that makes sense right there, yeah. And if I were to input 2 minutes, we'll only get how far you swam from 0 minutes to 2 minutes.
So if you subtract how far you swam from 0 to 2 minutes and 0 to 10 minutes, you will get how far you swam from 2 to 10 minutes.
Yeah, that's pretty well explained. That was easy to understand, especially when we already explained why the area under a function is the integral. Now I believe we've explained why 0 to 10 minutes minus 0 to 2 minutes is equals to 2 to 10 minutes. Now, if you just combine the two very easy to understand concept together, we'll get yb minus ya.
So, Ka, what did you take away from today?
Well, I mean, me and our audience there, we've learned that we've learned how to compute anti-derivatives. We have learned why integrals are useful, and we've also learned the fundamental theorems of the calculus rules.
Until next time, I'm Bree.
And I'm Ka.
Bye.